What's going on, everyone? My name is Johnny Bannon, and I will be your CCNA instructor for this CCNA video series. In this video, we're going to go over our first section in section 6, which is going to be NAT, which stands for the Network Address Translation. So let's just go over the agenda of what we're going to go over, right? So, first thing we got to discuss is just what is NAT, a quick overview of what the Network Address Translation Protocol is, and then we'll jump right into why we need NAT. NAT is very important for our communication over an IPv4 network, which is, of course, if you're in the US, what we mostly use still, IPv4. NAT allows us to use private RFC 1918 addresses. And we're going to go over how that is done, of course. And then we got to go over the NAT terminology. So a quick overview, why we need it, and let's just dive in to the terms you're going to see in NAT and why those are also important as well and what they mean, because there is a lot of terminology in NAT that I've noticed my students definitely get confused on, and I don't blame them because a lot of similar language. And then we're going to go over the different types of NAT that you can employ on your environment. There's 3 types: static, dynamic, and then PAT, or overload, or port forwarding, and Cisco terms, that's called port address translation. The most important one, in my opinion, for a junior network administrator to know about, because that's what probably 98%, with a made up number, 98% of enterprises use overload. And then we're going to dive into the configuration of all 3 types of NAT. So on our actual lab environments, we're going to go over 2 labs, and that's static NAT and overload. We're not going to do the second type of NAT, which is dynamic, because it's just one extra line of command, and I'll discuss that in the slides, what that looks like. So with that being said, let's go ahead and get started. So NAT overview. So the Network Address Translation Protocol is going to allow organizations and companies to convert those private IP addresses, which are only supposed to be used in your LAN, to a public routable IP address. And through that conversion, our customers or our users here with that private IP address are going to be allowed access to the internet. Through that translation of the public IP the public IP that sits on the edge of our router, of our demarcation point. So NAT will typically be configured at the border router of your network. So, and this is a stub network, so that's our border router. But let's say you're in a much more complex network, maybe a 3-tier core topology with a router at the end of the core. That's typically where you want NAT to be done. The router that has your connection to the internet, and then your inside connection to your enterprise or your LAN. And then NAT will only translate private IPs to a public IP when necessary. So what that means is, depending on how you configure it, like let's say we have our router here at HQ, and then we have another PE router here, and then we have a spoke site. Spoke. And these are geographically diverse, meaning this could be in Phoenix. This is in New York City. And let's say we build a tunnel. That tunnel, we may want to keep that private IP addressing because that's the subnet we use within our enterprise. And if you configure NAT correctly, it'll only NAT connections going out to the internet, not through that IPsec or GRE tunnel. Also with that, NAT does have other functionalities that we're not going to necessarily go over because they're not on the CCNA exam objectives. But you can do NAT over VPN if you need. You can do NAT over, or you can use NAT for like IPv6 to 4 or 4 to 6 mappings. So there is other use cases for NAT that are beyond just the normal change my private IPs to public so I can get on the internet. But we won't cover that in this series of videos. Now, NAT is everywhere, guys. I mean, you can go on your home router right now and see, if it allows you to see the NAT translations, that you have a public IP on probably what they call a WAN interface, depending on your router at home, and then your Wi-Fi network is going to be private IP addresses. So I 100% guarantee that you guys sitting at home, if you have an IPv4 address, it's private on your computer, and then your home router is actually doing NAT, and more than likely doing PAT or overload or port forwarding. So that's just a quick NAT overview. As you can see here in our little diagram, this allows our network down here to reach this public server. So why we need NAT? So NAT really is the only solution we have for the global use of private IPv4 4 addresses. I gotta remember to keep that in there, right? Because there is a version 6. And what this means is that users within a LAN can still be assigned those RFC 1918 addresses and still be able to communicate on the internet because of NAT. So NAT alleviates the scarcity of public IP addresses. The whole point of NAT and private IPs was we were running out of public IPs, IPv4 addresses. So NAT was that solution in conjunction with RFC 1918 to still allow internet connectivity for enterprises and home networks all across the world to communicate by only assigning one public IP to your connection outbound to your ISP, your WAN, or your internet. So, and as you can see in this diagram, look at all these different companies. They may all use the same service provider. Maybe they're located in one city, and they all have the same private IP address. And this is possible because they all have different public IPs, which is doing the translation for this entire network here. When I first started, that always confused me, right? Because usually CCNA courses, they say IP addresses are always unique, always, always, always. And then you see the 192.168 address everywhere. You're like, wait, what? That's not possible. And then you get to the NAT section of your first training in networking. You're like, oh, all makes sense now. Okay, moving on. Sorry, getting sidetracked. So now going over NAT terminology. So this is the part that I know confuses a lot of my students, and even myself when I have to teach NAT, I definitely go over this again prior to the video. So the first two terms we're gonna go over is the inside network and the outside network. So this is gonna be the set of devices on a LAN using private IP addresses. And also the inside network is also just your router's connections. And when we say router, remember, we know there can be a layer 3 switch because I know people like to be sometimes stump to chump. Whatever device is your connection out to the internet, the networks on that router are your inside network. So what that means is this right here is going to be your inside network. So that IP address right here at the customer edge 1 router is also considered part of your inside network. It's just going to be the inside global address, right? So you see here we have an inside local and inside global address. So let's define those. So we know we have an inside network, and that's going to be our enterprise. And our enterprise is all of our devices and our IP addressing assigned to us. So let me clean this up real quick. So in the inside network, we also have 2 different definitions. We have an inside local address or addresses, and then we have the inside global address or addresses, and we'll go over that when we get to like NAT pools. The inside local addresses are going to be your private IP addresses. These are the ones that are going to need to be translated. The inside global is that public IP address assigned to your router that faces the internet or your ISP. And this is going to be what gets translated. So your inside local addresses are going to be translated to your inside global addresses. As you can see here, this SA stands for source address. So initially when that packet is created on PC1, it's going to generate that IP packet, and the IP header, you're going to have your private IP, your inside local. And then what they call the outside local is really just the destination. And the outside local and outside global, they may be 2 different terms, but they mean typically the same thing. And for CCNA, that's how we're going to use it, right? Because to go into when these would differ is when you have NAT on both sides. Maybe you have a proxy server, so we're not going to get into that. But the outside local and outside global is just going to be the same destination address. When that IP packet hits your NAT-enabled router or your layer 3 switch, whatever device is doing NAT, what's going to change is that source address is now going to be changed to the inside global address, which is, ding, 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 your public IP on your router. And then the outside global address just stays the same. It just gets a new definition, I guess, right? So again, DA guide stands for destination address. And that's going to be the terminology. And I know this gets a little confusing because even looking at it right now, you can't just decipher automatically what is the inside local and inside global. So we'll be sure to try to break that down in this video as best I can. But yes, there are 4 types of addresses used to describe NAT communication. Key thing to remember that always confused me starting out is that outside local and global address is the same thing because that's the destination address. And as you know, destination addresses should never change in an IP packet traversing to its destination because we need that destination address on every hop so routers know where to send your packet to. So let's just take a deeper dive into this, right? Some communication. So as we can see here, we have PC1. This is our inside network. And then we have this address right here. So this is going to be our let me write that so I don't misspell, right? So this PC address, which would be like a user, this is going to be the inside local address. And then the public IP that sits at your border router facing the outside network is going to be your inside global. And if you think about just the word we use here, global, it makes sense because that's the IP address that does belong to us, our enterprise, but it's used for global communication. And then your outside local and your outside global are going to be the same IP address, which is the web server that PC1 wants to talk to. So this is going to be our outside local and global. So let's go over this communication. So PC1 is going to generate that IP packet. The IP header is going to look like this, with the source address being its private IP, destination address being that web server's IP address, which is global. It's going to hit our NAT-enabled router, and the source address is going to change to our inside global address, which is again our public IP. And then the destination address stays the same, but now we call it the outside global. And I'm pretty sure they just use this terminology to describe that now the IP packet's outside of our network when it transits past this NAT-enabled router. So that IP packet's now going to reach its destination. The web server is going to get whatever request it is. Let's say it's a web server, which, yeah, it's a web server, so it's HTTP request. It's going to do its de-encapsulation process. It's going to look at this IP address and say, okay, that's where this packet came from, so I'm going to respond to that IP address. So now let me build my IP header, and the outside global stays the same, and this is meant to say global, so that's something I'll have to change. The inside global address stays the same. That packet's going to get sent off to R2, and when it reaches R2, he's going to have what we call a NAT table in here that's going to record that initial communication that was made and say, okay, I just received this IP packet. It's coming from the web server and it's destined to me, but there's going to be, let's say, two things, either a static NAT translation where this IP address and this IP address match each other, meaning when you're sending to this guy, you're always going to go to this guy. Or if we're using PAT, port address translation, there's going to be a unique ephemeral port on here that's going to match that inside local address. Or it's going to know that, okay, it came back with this port, so I know that it needs to go to my guy right here, 192.168.5.10. So that's kind of how the communication goes. So this router is going to hold that table that has those NAT translations and knows about it, right? And we're going to go into that and I'll show you what that table looks like on the actual CLI when it comes to our labs. So now that we went over NAT terminology, and hopefully that didn't confuse you too much, maybe just play me at half speed and go over it a few times. Let's go over the different types of NAT. So we have three major types of NAT that we're going to discuss. We have static NAT, which is going to be a one-to-one mapping. We have dynamic NAT, which is still technically one-to-one mapping. But with dynamic NAT, we can define a pool of both private and public IP addresses to be translated to. And we'll go over dynamic NAT a little bit more and when you would use this. Really, I don't see a use case for it. Maybe in certain server deployments where you have proxy servers and stuff, but we're still going to go over dynamic NAT. Then we have PAT, which stands for Port Address Translation, which allows essentially one or many to one mappings. With, this being the private IP addresses are allowed to get mapped to one public IP. So we could have a /24, or really we could have a /16 of public IP addresses on our enterprise that all get converted to one global or public IP address. And that's, again, the one that we always use. That's the best use case. PAT is going to be used in all of our enterprises and all of our home networks. So that being said, let me just go ahead and stop this video. We're at 15 minutes. And then let's join for part 2. Let your brains decompress. And we're going to jump right into the different types of NAT and kind of the NAT translations and how they work. So thank you for viewing.